I'm sharing my screen. Hope you are aware of this sequence detector. But one more time, I'm drawing the sequence detector. So basically, there is a Mealy machine and Moore machine. So Mealy machine, if you take Mealy, is output depends only on the present state only. Okay. So if you see the Mealy, so in digital you already studied. So your prerequisites are digital design. So Mealy output is function of present input and present state. Okay. So there are two types like non-overlapping and overlapping. Okay. So we design a sequence detector by using this Mealy FSM. Okay, finite state machine. In the sequence detector, you have Mealy non-overlapping and overlapping. Okay, non-overlapping and overlapping. Okay, so if you see the non-overlapping, the last bit cannot be the first sequence. Okay, so when sequence is detected, so freshly it will start. Okay, and overlapping means the last bit becomes the first sequence. Okay, so that we you seen in the digital. Suppose if I want to draw the FSM diagram. Okay, FSM diagram for sequence detector, that is 101 sequence detector, Mealy, Mealy, uh, non-overlapping, Mealy, non-overlapping. Okay, how to draw this non-overlapping? Okay, so if you see non-overlapping, uh, so so here for Mealy machine, how many number of bits you are searching, that many number of states you have. Okay. So initial state is, so you have three states, S0, S1 and S2. Okay. So you are at S0. Okay, S0. Um, so you can expect 0 or 1. If it is 0, it will be in the same state. Okay. And this is input by output. Okay. The state diagram will look like this for Mealy machine. So this is a state. This is one more state. Okay. So when it is going from one state to other state, input by output. Okay. So input is 0 and output is 0. Okay. So when sequence is detected, it will go to the next state. Okay. So this is S1. Okay. So when the sequence is detected, output becomes 1. Okay. So here it is going to S1. So here you got the sequence 1. Here you got the sequence 1. Okay. And next, so in this you need to search for 10 or 11. Okay. So if it is 10, it will go to the next state. It will go to the next state. It will go to S2, 0, and output is 0 only. If it is 11, it will be in the same state only. Okay. So this will be 1 and output is 1. Okay. So here you got the two sequences, that is 10. So next you can expect 100 and 101. Okay. So 100 means for non-overlapping, if it is 0, it will go to the initial state. Okay. That is here it will go to S0. So this is 0. You didn't got the sequence, output is 0. And if it is 101 also, so when the sequence is detected, freshly it will start. Okay. So when sequence is detected, the last sequence cannot be the first sequence. So freshly it will start from the next sequence. So when the sequence is detected, it will go to the next state only. Okay. So for this one, okay, one sequence is detected. So one by one. Okay, one by one sequence is detected. This will go to S0. Okay. Hope you understood. Any doubts or queries in this? Or shall I explain one more time the sequence detector one by one? This is one by one. Here you can expect 10 or 11. You understood the sequence detector? Shall I move forward with programming? Waiting for your response. Shall I move forward? Hello.
Yes.
Did you understood this diagram?
Sir, this last part I did not understand. This S2 to S0 transition.
Yeah,
Uh,
yeah,
how?
S2 to S naught. So,
Yeah.
S2 to S naught means if it is zero, so where is the initial state? It will go to the initial state. That means if it is zero, it will go to the initial state. Okay. If it is one also, it will go to the initial state. Suppose if you take the random pattern, suppose let us take the input pattern. Okay, let us take this input pattern. So if you want to analyze this diagram, just to take random pattern. Okay, so let us take one input pattern, uh, uh, 0, 1, 1, 0, and 1, 0, 1, 1, 0, 1, and 0, 1, 1, 0, 0, 1. Okay, so if you are writing for Mealy non-overlapping, so this will come in the digital. Okay, so 0 means you didn't got the sequence, output is 0 only. 0, 1 means output is 0 only. 0, 1, 1, output is 0. 1, 1, 0, output is 0. Okay, here you got the sequence. So I am searching for which sequence means 1, 0, 1. Okay, so here 1, 0, 1, I got the sequence. Okay, 1, 0, 1, I got the sequence. So the output becomes, immediately the output becomes 1. Okay, for the Mealy machine, when the sequence is detected, immediately output becomes 1. Okay, as this is non-overlapping, so the last sequence cannot be the first sequence. Okay, freshly it will start. Okay, it will start from 0. Okay, so 0 means 0, 0, 1 means 0, 0, 1, 0 means 0. Again, here you got the sequence. The output becomes 1. So this is output becomes 1. Okay, and again freshly it will start. This is 1, and 1, 0 means output. You didn't got, this is 0. This is 0 only. You didn't got the sequence. 1, 0, 0. This is 0, and 0, 0, 1, 0. So this is the Mealy non-overlapping. So if you are getting 0, it will go to the initial state. Where is the 0 is there? Here input 0 is there, no? So that's why it will go to the 0 state. So here 1 means you got the sequence. 1, 0, 1, you got the sequence. Okay. So when next sequence, it will start freshly. So it should start from the initial state. This is nothing but a reset state. Is it fine? Do you understood?
Yes, sir.
Okay. Yeah. Like this, you need to analyze. Okay. So
Uh,
I'm going for the
for
program. Yeah.
yeah, for S1 it will be if you get one as input, it will be zero output, right?
Yes, one.
S1 stage.
I'm not understood your question. Tell me, please tell me.
That S1 state, right? S1 state.
Yes, one state.
So for one input you have given output as one, right?
Sorry. This is zero only. Till the sequence is not detected, the output will be zero only. When the sequence, here the sequence is detected, so output becomes one. Yes. Thank you for uh, giving the mistake. Now is it fine?
Yes.
Anyone? Any doubts or queries? Shall I
No.
move forward?
Yeah.
Okay. So if you see the coding part, so here, one second. Mm, yeah. So I wrote the code in the GVM editor. GVM editor is a free open source software you can install. Okay. So I wrote the code for Mealy non-overlapping. Okay, this is the code for Mealy non-overlapping sequence detector. So here if you see, first module, what is my module name? Mealy 101 detector non-overlapping. Okay, so we need to declare, so as I am using behavioral modeling, input wire clock, input wire reset, input wire DN, output I need to declare with rich data type. Okay, here I am declaring the input sound output within the bracket itself. and I need to declare the parameter. Okay, there are two types of parameter is there. One is one parameter, and this local parameter means this S naught is related to this local. Okay, so for this I will declare with local param. Okay, local param S naught equal to, I will give the states for this S naught, S1 and S2. Okay, for Mealy machine you have three states, no? So S naught equal to 2 tick binary 0 0 and S1 equal to 2 tick binary 0 1 and S2 equal to 2 tick binary 1 0. Okay, and I will declare two more variables, that is with respect to reg data type, that is 2 bits 1 down to 0, current state and next state. Okay, one is current state, one is next state. Okay, so remember, state transition logic is sequential logic, and next state logic is a combination logic. Okay, that you need to remember. Okay, state transition logic, whatever the state transition logic, okay, is a sequential logic, and next state logic is a combination logic. Okay, so here if you are first you are writing for the state transition logic, always at the rate passage of clock or passage of reset. Okay, begin if reset equal to 1, current state equal to what? It will start from where? S naught only, no? If reset is 1, okay, it will start from S naught. Okay, end. Else begin, current state equal to next state. Okay, so that means if reset equal to 1, it will start from S naught. If reset equal to 0, it will go to the next state. Okay, so this is the end and end. Okay, so this the begin is there, no? This end. Okay, so this is the logic for state transition logic. Okay, this is synchron, like this is a sequential in nature. Okay, that's why we are using non-blocking and sequential in nature. And coming to the next state and output logic, this is combinational in nature. Okay, so always at the rate current state or input begin. Okay, so you need to see the diagram and you need to write these cases. Okay, next state equal to, that is default state is S naught, and what is the output? Output equal to 0 only. Okay, output equal to 0. I am using case statement. Okay, case current state, you are at S naught. Okay, you are at S naught. Okay, so when you are at S naught, see here, you are at S naught. See this diagram and just analyze the code. Okay, if input is 0, it will be S naught only. If input is 1, it will go to the next state. Okay, see here, if din equal to 1, begin, next state equal to S1, and else begin, next state equal to S naught only. Okay, so that means when input equal to 1, it will go to S1, otherwise input equal to 0, it will be in the same state only. Okay, and next 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 we are at S1. Okay, S1 begin, if input equal to 0, next state equal to what? S2. Okay, end, else begin, next state equal to S1, end. Okay, so here if you see the diagram, you are at S1. Okay, if input equal to 0, it will go to the next state, S2. If input equal to 1, it will be in the same state. Okay, that only I wrote. If input equal to 0, it is going to the next state, S2. If input equal to otherwise, it will be the same state. Okay, and next if you see, uh, you are at S2. Okay, begin. If input equal to 1, where it should come? That means 101. Sequence is detected. So output should become 1. Okay, output should become 1. One second. What happened? Okay. One second. Now I'm opening this. Yeah. So don't worry, I will share this codes. Okay. Uh, so you are at H2. So if input equal to 1, the sequence is detected and output becomes 1. So what is the next state? It is going to S naught only, no? It is going to S naught only. Okay. So that is, it is going to S naught only. And else begin, D out equal to 0. If D out equal to 0, next state equal to what? False condition. It is going to S naught only. Okay. It is going to S naught only. Okay. So like this, we can see end case, and end model. Okay. So by seeing this diagram only, I am writing the next state logic and output logic. Did you understood this code? Any doubts or queries? Hello.
Yes.
Okay. Next, coming to the test bench. So I wrote the test bench. Okay. Test bench for all the sequential circuits are same only. Okay. That 5 steps you need to follow. So Mealy 101 non-overlapping. Okay. Mealy 101 non-overlapping. Okay. So here you see module TB Mealy non-overlapping 101 detector. So you need to declare the internal variables. Okay. Whatever the clock, reset, and in, I'm declaring with reg data type, and wire I need to declare with wire data type. So this is you need to follow the port rule connections. Okay, related to the test bench, and you need to instantiate your design. What is your design? Mealy 101 detector. This is your design name. Okay, non-overlapping DUT dot clock. Okay, clock, this is nothing but connection by name. Okay, so whatever the variables outside the bracket are nothing but design inputs and outputs, whatever the variables inside the bracket are nothing but test bench variables. Okay, and clock generation, how we are generating? Initial begin clock equal to 0, forever hash 5 clock equal to not off clock. So you are, so if the clock is 1 nanosecond, you are generating the clock period of 10 nanoseconds. So this is off for 5 nanoseconds, on for 5 nanoseconds. Okay, okay, 5 for nanoseconds. Okay, and next between what happening, I don't know. Okay, so next, yeah, you need to give the stimulus. Okay, first step is declare the internal variables. Next step is instantiation. Next step is clock generation, and giving the stimulus. Okay, so initial begin, initialize first reset equal to 1 and in equal to 0. So after 10 time minutes, if you apply reset equal to 0, so you need to see different test cases. See here, for every 10 time minutes I am giving 101. Here output becomes 1. Okay, after that it detects 0. Okay, test 2 cases I am giving 1 1 0 1, and after that 0. Here d out should be 1. Okay, and test case 3 I am giving random sequence, that is 1 0 1 0 1 0 1. Here sequence is detected. Okay, the output should be 1. Okay, and after that, after 10 time minutes, simulation complete, dollar finish, end module. Did you understood this test bench? Any doubts or queries? For the sequential circuits, you are following all the same for the all the sequential circuits. That 5 steps you are following. What are those? Declare the internal variables, instantiate your design, and clock generation, and initialize the edge variables, and give the stimulus to the design. Have you understood? Any doubts or queries in this test bench?
Yeah,
Got it?
understood.
Okay, yeah. So here if you see, I'm opening the Xilinx Vivado. Okay, so I'm opening the Xilinx Vivado. What about others? Please give response so that I can move forward whether you are understanding or not. Okay, so create a project, new project. Next, my project name is sequence detector using Mealy FSM. Mealy FSM. Okay, so go to, so I need to go to the project now. So here I need to go to training and development. Mm, training and development. My digital and Verilog course. RTL weekend batch. So I need to select this code. Okay, RTL codes using Xilinx Vivado. Okay, so you need to select this path. Okay, select this path. Okay, next. Okay, next, and create the source. Okay, so what is my source? One second. Create the source here. This is let us take the module name is this one, Mealy 101 detector non-overlapping. Okay, copy and create my file name. That is, this is my file name. Choose the location. So sequence detector using Mealy FSM. Okay, next, next. That the constraints is optional only. Next. So this will select the part number. Next, finish. I'm creating the project. So module name is also same. I can give module name, file name, both are same only. Nothing will happen. Okay. So this is my design. Okay. So go to this GVim. This is my code now. So copy this and paste here. Save this. Um, Save this. Okay. After that, go to the simulation sources. Add the simulation sources for the test bench. So what is my test bench name? TB underscore Mealy non-overlapping 101 detector. Copy this and create your file name, and where you need to store sequence detector using Mealy FSM. OK and finish. My test bench file is created. My TB file is created. Okay. So just remove this, not required. Delete this, and this is my test bench file. Select all, copy and paste here. Okay, paste here and save your file. Now my design is instantiated on this. What is my design name? DUT, design under test. This is instance name, and my design name is Mealy 101 detector non-overlapping. Okay, so I wrote the design as well as test bench. Okay, I wrote the design as well as test bench. Okay, so run simulation, run behavioral simulation. Second. Hmm? One second. Why I am getting error? What error I am getting? Okay. One second, I will close this. I'll open the code wherever. That process you understood, I think so. Mm, MATLAB programs, FSM sequence. I'm opening this project. So Mealy FSM non-overlapping. Same code I wrote here. Same code, whatever I explained. So this one you need to make a stop module, test bench. This one I need to make a stop module. Okay. So run simulation, run behavioral simulation. So here you got the output. Okay. Here you see these are the testing simple sequence. So here what happens when reset equal to 1, okay, reset equal to, this is reset equal to 1, all the outputs will be 0 only, and when reset becomes 0, So you need to check for the sequence. Okay, what sequence we have given. Okay, so just zoom this. So here I am checking for the sequence. D input, first I am giving 0, 1, next I am giving 0, again 1. Here what happens? The sequence is detected. Okay, in the test bench what I wrote, see here, 1, 0, 0, 1 and 0. Here output should be 1. Okay, so here 1, 1, 0, 0, again here 1. Okay, output should be detected. Okay, and next sequence what I am giving, 1, 0, 0, 1. Okay, here also I need to, one second, sorry. Here I am checking this one. Okay, sorry. I'm checking for, I need to check for this one. I need to set as stop model. I need to set as stop model. This one I need to set. Okay, this one, this test bench. Okay, uh, so whatever you are searching, that you need to set as stop model. Run behavioral modeling. So if you see this test bench, fit to page. So in the test bench, what I am giving? So 101, again 101. Okay, 101. Oh, non-overlapping. This is non-overlapping. This is non-overlapping. Okay, not overlapping. This is non-overlapping. Okay, so again run simulation, run behavioral simulation. So if you see here, fit to page, what is the first stimulus I gave? 1010. Okay, so when reset equal to 1, all outputs will be 0 only, and reset becomes 0, then it will be in the functional mode. So here I gave 1 0 1. Okay, output becomes what? 1. It is detecting 1. Okay, so after that, so separately, means freshly it will start. Okay, so again it becomes 0. Again, which stimulus you are giving? 1 1 0 1 0. Okay, so 1 1 0 1. So here output becomes 1. Okay, I got the sequence. Here I got the sequence. So output becomes 1. Okay, so test 3 I'm checking for random thing, 1 0 0 1 0 1. Here output should be 1. Okay, so next 1, next where it is the 1 0 0. Okay, this is 1 0. Okay, during this passage of clock I need to check 0 0. Okay, again 1. Okay, 1 0 0 1, again 0 1 0 1. Okay, 0, again I am making 1. So that means here output is detected. Okay, so when 101 sequence is detected, so output becomes 1. Okay, you understood the non-overlapping sequence coding part?
Yes.
Okay, yeah. So next we'll see the overlapping sequence. Okay, we'll see the overlapping sequence. Okay, so what is this overlapping sequence? We'll see. So 101 Mealy overlapping. Okay, so hope you understood the coding part. So I'm moving forward. So any doubts are there, please interrupt me and ask me. I will tell you. Okay. So 101 sequence detector Mealy FSM non-overlapping. No, sorry, overlapping. So we completed with non-overlapping. No. So next we need to see for overlapping. Overlapping. Okay. So yeah. So if you see here, so I need to detect 101, no? You are at S naught. You are at S naught. Okay, this is reset state. This is reset state. So we can expect it every sequence. You can expect 1 or 0. So if it is 0, it will be in the same state only. So 0 by 0. If it is 1, it will go to the next state. S1. Okay. So here you got 1. Next you can expect uh, 1 0 or 1 1. Okay. If it is 1 0, where it will go? It will go to S2. Okay. So 0 by 0 and here 1 by 0. Okay. If it is 1, it will be in the same state. 1 by 0. Okay. And next you are expecting. So here you got the sequence. What is the sequence you got? 1 0 you got. So next what you are expecting? 1 0 0 1 0 1. Okay. So here 1 0 0 means, so as this is overlapping, you need to check for 2 bits. 2 bits anywhere matching, it's not matching. 1 bit is matching. So 1 bit is matching. Okay. So where it will go? It will go to S naught. 0, output is 0. Okay. Again, if you see this 101 sequence, 2 bits I need to check. Okay. 2 bits anywhere matching. 0 1 anywhere matching, not matching. 1 also not match. So 0 1 not matching. 2 bits not matching. I need to check for 1 bit. So 1 bit is matching. Where it will go? It will go to S1. It will go to S1. Output input is 1 and output is 1. So this is the sequence detector for Mealy FSM overlapping. Have you understood this? Or shall I explain with random pattern?
Understood.
Okay. So shall I explain with random patterns? Let us take input sequence. Okay. Input sequence. Okay. Same sequence you take. Okay. So what is my sequence? 0 1 1 0 1. Okay. 0 1 0 1 1. Random pattern I am taking. Okay. 0 0 1. Okay. So this is Mealy non-overlapping. Mealy overlapping. This is Mealy overlapping. Mealy overlapping. Okay. If you check this, so 0 output is 0, 1 output is 0. Again, 0 1 1 output is 0 only. And next 1 1 1 0 output is 0. 1 0 1, you got the sequence. Okay. So output becomes 1. Okay. As this is overlapping, the last bit becomes the first bit of the sequence. So that means this will be means included. Okay. So 1 0 means the output is 0. 1 0 1, the output becomes 1. You got the sequence. Okay. Again, the last sequence becomes the first sequence of the first bit of the sequence. Okay. So 1 0 means this is 0 and 1 0 1. 1 0 1 means here you got 1. Again, last bit becomes the first bit. 1 1 means 0 only, and 1 1 0 means 0 only. Again, 1 0 0 output is not detected, 0, and 0 0 1 output is 0. So like this you need to analyze. Have you understood this? Any doubts or queries? Shall I move forward?
Yes.
Okay. What about others? Shall I move forward?
Yes, sir.
Okay.
Sir,
Yeah.
just one thing, we are detecting 101 sequence, but
Ye-
if this sequence is very large, then this state machine will become large.
Yes. Yes. Yeah.
Okay.
Hmm. So most of the like IPs and this SOCs, normal big circuits, they follow the FSMs only, finite state machines only.
Okay.
Example like lift is there. Okay, lift is based on FSM only. No, like you are in third floor. Okay, so Suppose second floor, that is based on the priority level. Okay.
Mm,
So somebody is there in the fourth floor. So
mm.
first it will go to the fourth floor, and they will that will pick up, and it will stop in third floor, like that. It is nothing but a sequence of operation, like
Mm,
chocolate vending machine, or any application if you take, that is based on FSM only.
okay.
Okay. Yeah. So in order to understand that complex systems, you need to understand the simple sequence detector. Okay. Your doubt is clear? Shall I move forward? So this is, if you see this one, 101 overlapping. So this is the code for 101 overlapping. So if you see 101 overlapping, okay, I will show you with GVim. It will be more clear. Sequence detector Mealy RTL 101 overlapping. Okay. So this is 101 overlapping. So you need to declare a module. What is my module name? Mealy 101 overlapping detector. So input you need to declare with wire data type. So input wire clock, input wire reset, input wire input D in. Okay. Output, as you are using behavioral modeling, output it should be reg data type. You need to declare the states with local param. So for the Mealy machine, you have 3 bits, means three states are there: S0, S1, and S2. So S0 I am declaring with 00, S1 is 01, and S2 is 10. And I need to declare two more variables, that is current state and next state, with reg data type by using vector 1 down to 0. And as I told you, know that next state logic, okay, current state transition logic is sequential in nature, and next state logic is combinational in nature. Okay. So state transition logic I am writing always at the rate passage of clock or passage of reset begin if reset, equal to 1, begin current state equal to what, it will start from the S naught. Okay. And else begin current state equal to next state with non-blocking. Okay. So with non-blocking assignment, I need to declare with this state transition logic. And after that, next state logic is a combinational logic. Okay. So always at the rate current state or dn begin, you are at next state. That is next state equal to what is not only. Okay. If current state or dn, okay, any, this is nothing but sensitivity list. Whether you are in current state or whether the input is dn, so these events occurs. So next state will be default state is, it will start from S naught only. Okay. D out equal to what? Default output is 0 only. Why? Because sequence is not detected. So default state is 0 only. Okay. And case, I am using case statement. Okay. That is procedural statement. Case statement I am using. Current state. So that is current state. So you are at S naught. Okay. See this diagram and just analyze. You are at S naught. Input is 0. It will be same S naught only. And input is 1. It will go to the next state. Okay. So any of the bit in the sequence is detected, simply it will go to the next state. Okay. That you need to remember. See here. So you are at S naught, begin. Just see the diagram and just write the logic. If dn equal to 1 tick binary 1, begin, next state equal to what? S1. And else begin, next state equal to S naught. And end. Okay. So this is S naught. Okay. And next you are at S1. Okay. You are at S1. See this diagram and analyze. If input is 1, it will be in same state, S1. Input is 0, it will go to S2. Okay. So see here, if you dn equal to 0, you will go to, so you got second sequence in whatever the sequence you are checking. Next state logic it is S2, and else begin. Next state equal to what? So false statement. If it is 1 means it will be in the same state only, stay in the S1 only. Okay. End and end. Okay. And see the diagram. Now at S2, okay, input is 0, it will go to S naught. Okay, input is 1, it will go to S1. Okay, See here, if D in equal to 1, so you got the sequence 101 sequence begin, D out equal to what? Output becomes 1. So it will go to which state? S1, no? It will go to S1. Okay, next state equal to what? S1. Okay, as this is overlapping, final one is the starting point. Okay, so final bit is the starting bit of the next sequence. Else begin, D out becomes 0. What is the next state? It will go to S0. It will go to S0. Okay, so next state equal to S0. You need to end this and need to end this begin, and you need to end this one and end case end. So always at the rate this begin is there, no? This you need to end and end module. Is this code is fine? Do you understood? Simple, no? Just seeing the diagram and I'm writing the logic. That's it. Next state logic, seeing the diagram and writing the logic. So I'm writing within the case statement and I'm using if else statement like this. Shall I move forward?
Yes.
Okay. Next, if you see test bench, if you see the test bench, Mealy overlapping. Okay. Test bench is same only. That instantiation will change. That's it. Okay. So that 5 steps are there. First, you need to declare the internal variables. What are the internal variables? Reg, clock, reset, dn. Okay, with reg data type and d out with white data type. So you need to instantiate. Instantiation is nothing but you are calling your design in the test bench. That's it. Okay. Instantiation is nothing but it's like a in the C language you are using functions, no? Okay. So in the system Verilog you are using classes. You are calling your classes by objects. Okay. So same like that. Same like that. Here instantiation is there. Okay. There is some OOPS concept will be there. System Verilog. Okay. So Mealy 101 overlapping detector DUT, whatever the variables outside the bracket are design inputs and design inputs and outputs. The variables inside the bracket are test bench variables. And next generation of clock. Initial begin, first clock equal to 0. Forever, #5 clock equal to not of clock. End. And so this is you are generating the clock with 10 nanoseconds. Off for 5 nanoseconds, off on for 5 nanoseconds. Okay. And next you initialize first you are initializing the inputs. So reset equal to 1 and d in equal to 0. After 10 time units you are applying reset equal to 0. So that means first you are asserting the reset, next you are deasserting the reset. Okay, you are seeing the test cases. Okay, so here 101 d out becomes 1. Okay, after that 101 means what? Here d out becomes 1. Why? Because this is overlapping, this one also included. Okay, and next this is simple test case 101, and this is also simple test case 110 101. Okay, here you need to find out, identify. So 101, the output becomes the output of the sequence becomes the first bit of first sequence, the next sequence. So again 101, the as this is overlapping, d out becomes 1. Okay, so I can see in the vivado, is this test bench is fine? Do you understood? Please give response so that I will move forward.
Yeah.
Okay, yeah. So here I wrote the code for 101 overlapping. Okay, so whatever I explained, the same thing. So in the simulation, what I need to do here, this is the test bench. This test bench, I need to make set as top module. Okay, set as top module. Okay, so Mealy overlapping 101 Mealy overlapping. Okay. This I am closing. This is Mealy overlapping code and Mealy test bench. Okay. So I made as top model. Sorry, 1001 I made, no? 1 second. 101 overlap and you make a setup top model. So run simulation, run behavioral simulation. So if you see P2 page, so what I gave TB, this I am closing. Okay. So first sequence what I gave 10101, no? So you see this one. So when reset equal to 1, the output will be 0 only. So I gave 101. Okay, I gave 101. Okay, so from here 1 0 1. Okay, 101. The output becomes 1. Okay, after that I am giving the input as 1 0 1 0 1. Okay, see here. First I gave 101. Output becomes 1. Okay, here output becomes 1. After that, I gave again 101. Okay, this output, this sequence becomes the first sequence 1 0 1 0 1. Output becomes 1. Okay, here output becomes 1. Okay, after that I gave 0. Okay, I gave 0. This is 0, and next next 1 I gave. Okay, so 1 I gave means here also 1 1 0 again 1. Okay, output becomes 1. Okay, and next again 1 1 0 uh, 1. I got the sequence. Okay, here also 1 0 1. I got the sequence. Okay, I'm giving this sequence 1 0 1. I got the sequence. Here also 1 1 I need to give first. Next 1 1 1 1. Okay, 1 1, and next 0 1. I got the sequence. So that means output becomes 1. So like this, you need to check the output D out with respect to the input sequence. I am giving the stimulus to the design. Design is processing, and design give the output, that is input to the test bench, or input like test bench simulation part. Have you understood any doubts or queries? Any doubts or queries? This coding part and all those things.
No.
Okay. What about others? Shall I start more, or shall we do tomorrow?
We can do tomorrow, sir.
Okay, okay. So just I will share this code. One second, one second, one second.